Hello, thank you for joining Nihilent and Microsoft for our webinar. Today we're going to talk about digital trends and innovation in manufacturing. For this session, my name is Chaitanya and I've got Indranil here with me from Microsoft. And we're going to go through a couple of slides and a few demos to get you a background on how we see the digital trends evolve in the manufacturing industry. And from there, talk about how this can be beneficial for you, how you can use all the data and the information available to leverage for your business. So a little background before I hand over to Indranil. As we know, we've heard about Industry 4.0 or the fourth revolution, and that has come about from the background of multiple industrial revolutions. So the first one was steam, that allowed people to do more, that allowed machines to help people and carry more weight, lift more weight. Trains were a result of that. Then the next thing that happened was electricity. Obviously, we know how that's working out. It's a fantastic source of energy. And obviously, even with cars today, people are moving over to electric cars. The next one obviously was IT, electronics, all the technology that we see today in manufacturing. And while that is great, it still lacks an interaction between humans and the machines. And that's really the revolution we're seeing now as the digital revolution, where you could think of something like 3D printing or hologram, things like that, which are really, really exciting. Robots working across and alongside humans in factories to manufacture goods. So those are some very interesting things that are happening as the fourth industrial revolution. So with that background, I'm going to hand over to Indranil and have us talk to us a little about how he sees the recent trends in manufacturing, the digital trends. Indranil, over to you.
Yeah, thank you, Chaitanya. This is a very fascinating time, obviously, and with the introduction of the Industry 4.0, as what we heard from Chaitanya around this, the digital transformation is accelerating the way how manufacturing is evolving per se. And there are plenty of proof points. And in this particular slide, actually, I try to highlight some of those key trends that what we are seeing. And one of the things that we clearly see is the adoption of cloud as a technology that enabling a lot of these capabilities. And that's basically driving things like the manufacturing level, building out of the modern agile factories as an example. 80% of manufacturers expect that improved factory connectivity will help them increase their output levels. We are also seeing that the business model shifts, and any connected product, whether it is a machine or a commercial or a consumer product, customers, or rather the manufacturers, are moving more towards creating product as a service. And 83% of the manufacturers said that selling products and services would increase their profits. And that's obviously the reason that's driving the aspects around how the connectivity and the business value is going to be generated. And obviously, the customers are continue to become be the center of their experience. Yeah, and I think that's where the buyers would be basically looking for who has the best possible services and better customer experience and greater transparency across this whole ecosystem. On the technology front, what we have seen as the IoT as the starting point of the Industry 4.0, that has accelerated, and the numbers that were projected, 4 years ago, continues to grow as we see more and more things that are getting connected. That is one of the foundation for how the data is generated, gathered, collected, and inferenced. And that also causes a lot of challenges as well as opportunities. And what we see is that AI will continue to play, or rather get much more prominent in this particular space. And AI is more about, how do we infuse them into the environment, and definitely trying to gain insights that humanly is impossible to look into such a larger volume of information that gets generated. And I think the idea is that the AI will also improve the productivity. And over a period of time, what we will see is that machines will complete more percentage-wise work from 29% to 71% by 2025. And the conversation in the industry, obviously, is that what does it do to the workers and the jobs associated with that? As much as we have that whole conversation going on that there is a larger number of job that is being displaced. But what we have also seen that this is creating new opportunities. 133 million jobs as per the reports that are projected over here that highlight. And clearly, these are some of the key trends that we have seen. But then again, cloud usage is also bringing up some of the security challenges across the organizations. And what continue to see is that there's a significant investment that goes in the technology to be much safer, secure, to be able to use it. And it's an imperative. It's clearly an imperative for people who make that investment upfront versus being reactive to situations. And that is causing a lot more in terms of new dollars requires and the cost associated in dealing with such kind of security aspect of it. And so that's the broader context of it. But then again, the other things that we also see is that people have become much more conscious about the social responsibility. Sustainability also plays a significant role. We as an industry as a whole continue to use significant amount of natural resources, both energy, water, generate a lot of waste, and managing those becomes kind of critical aspect within the manufacturing. So overall, what we see is that the trends that have started, it just getting more and more accelerated, and technology is just enabling on how we deal with some of those aspects of it.
So that makes sense. That's really good in terms of how I suppose you could call it more of we're leapfrogging into a new way of working.
Yeah, and from Microsoft perspective, we always have our vision around creating this construct of the intelligent cloud and intelligent edge. And three things are happening simultaneously in this particular space, based on those characteristics that you have seen. There is one part is obviously the experience. And in the experience layer, we are moving towards that people-centered experience. We are to some extent decouple that experience from the device, from the IO. And essentially, it is a multi-sense, multi-device, but it is part of the same application, same environment per se. As I mentioned, AI, we will see AI being infused in everything. It's going to have that perception capability, language capability, autonomy that goes into building into this application going forward. And to power all of these, what we need is this ubiquitous distributed computing fabric. And that's where Microsoft has been leading its vision around what we are calling it the intelligent cloud and intelligent edge. And by definition, intelligent cloud is an ubiquitous computing enabled by public cloud for every type of intelligent application and systems can envision. An intelligent edge is continually expanding set of connected systems, essentially, if you think of it that way, that gathers and analyzes data and can ubiquitously work within the edge or in the cloud, depending on, what makes the most sense, essentially in terms of whether that computing requirement needs to be closer to the data or both. And I think that's one of the power of conceptually the model created around this intelligent cloud. And when you combine these together, it provides that limitless computing power of the cloud and perceptive devices on the edge. And then that's basically a framework where we see the most value will be generated for most of these companies who are looking to create that next generation or driving that next generation, manufacturing scenarios.
That makes sense. So I know you mentioned a little about robots and machines taking over and jobs being displaced, but many more new jobs being created. So to that end, when you look up Industry 4.0, or if you were to just look at, say, videos or things that people are writing out on blogs, there's this concept of collaborative robots. Can you talk a little more of what does that actually mean? Where does the cloud play a part in it?
Yeah, absolutely. And I think the use of robots in manufacturing is nothing new, but this new generation of cobots, as it is called, is not an average machine that we have known from the past. And today's cobots are built with artificial intelligence, machine learning that power the cognitive capabilities. And these robots are able to use computer vision. For example, they can use vision to quickly inspect large quantities of items for flaws or defects, automate a transportation of materials, throughout a facility, using autonomous capability as an example, and avoid hazard using predictive intelligence as an example. And by design, cobots are collaborative, and these are being used to augment human labor rather than replace it. Now, by taking on repetitive, physically strenuous tasks, machines are making factories safer and more efficient for the human counterparts as such. And that's why the terminology obviously is being used. There are obviously fears that there will be job losses because of automation. AI will not only improve the labor safety, the working condition, but it will actually add jobs to the market space. And innovation in robotics have made these cobots more adaptable, compact, safer, more affordable per se. And I think, it's a trend that I think will continue to grow from that perspective.
Sure, that makes sense. And so for those sensors or, say even locations in factories and things like that, within the Microsoft space on Azure, I've seen something called a digital twin. How do you see that evolving? The reason I ask is, I'd seen some documentary for, I believe it was the Boeing factory. And it's so large that, when these robots move around, they have this guiding path that they go from A to B. To my mind, something like a digital twin tells you where that robot is at any given point of time, because you might have a layout of the factory. But are there maybe other scenarios where this could be useful in tying in IoT sensors and things like that?
Yeah, and I think the computing infrastructure, as well as ability to generate data from using the sensors at different level. And that's basically the foundation that's enabling companies to develop what they're calling it the digital twin. And you can think of digital twin is almost a digital version of anything that is physical. And it starts with an equipment. But that's probably the easiest thing that we can think of, right? I mean, the idea behind a twin is that you actually have a virtual version of a particular equipment, get to be able to work with that in terms of, for example, simulate conditions, understand if there are software changes being made, what is the impact on it, the overall physical environment. But I think the concept of digital twin has expanded even furthermore, essentially being able to look at it at a process level and goes beyond the process into an entire factory or between factories. And I think that's the most fascinating part of it, because now you are able to understand the impact across any of these environments before a physical element needs to be implemented, or even understand the implications of it. A great example could be you could use a mixed reality environment using HoloLens and visualize a digital version of a physical, any equipment, but in real time receive telemetry data from that equipment to see what it means. And its application can range from understanding that problems with the equipment or a failure, or even utilize it starting from training a particular person on how they should be working with that without physically interrupting the actual equipment itself, and then being able to understand and service it as it is required. And so there are many of these applications. What we are able to see are pretty fascinating. I think the opportunity is limitless, and I think we will be able to really see that digital twin becoming much more prevalent in every sphere of that manufacturing ecosystem.
Wonderful. So that makes a lot of sense. And I guess switching gears a little bit over to maybe the supply chain, because that's what feeds every manufacturing operation. From a standpoint of, say, tracking some of the raw materials that went into making a product, or so not necessarily a manufacturer in terms of product, but even maybe somebody who's in the food industry, and some parts of that are still considered a manufacturing operation, if it's a locally produced food or organic and things like that. Just as an example, do you think there is a place for a blockchain to be utilized for maybe managing the supply chain, making it a little more intelligent, and then even possibly using some of that data to feed the robots or feed the sensors, kind of make better decisions, faster decisions, and reduce overall cost and improve efficiency?
Yeah, absolutely. And I think fundamentally what we are seeing over here is that the data that is being generated further away from a manufacturer per se. And the traceability has always been part of that whole broader ecosystem manufacturing. Whether you're using signals, informations that are more transactional oriented or information oriented, starting with the early days of EDI. But those were rigid because, people needed to spend tremendous amount of time in implementation, and any changes required a lot more change management across that entire ecosystem. I think the clear requirement across this ecosystem has been all about trust. How do you work in that trust framework, create a trust framework in a distributed environment as complex ecosystems actually are forming? And more than the ecosystem forming is the agility with which you can actually do business. So I think blockchain, with its evolution, in its current iteration and generation, what we would say, provides a lot of that foundation of that distributed trust, as you can think of it. You are able to use that as a mechanism, not only to build that trust, but provide that transparency, provide the efficiency across that entire supply chain. And be it food, we as consumers, we always will think about where the produce is coming from. Has it been maintained with the right level of temperature or the condition in which it needs to be, and it has not been exposed to any kind of other external factors that are important to our health? And I think that as an industry is continuing to evolve, and we will see a lot more validation. And so parallels into the manufacturing too. If you really think about, I talked about the whole thing about the sustainability aspect of it. How does the manufacturer, if we have a corporate vision around maintaining sustainability and ensuring that products are being generated, my suppliers are being able to deliver me, a sustainable product, where it is coming from, with a reduced carbon footprint, etc. And I think, we see that being a blockchain can be effectively applied more from a transparency perspective. But I think its adoption has been always going to be a challenge because blockchain provides a new way of how you can rethink the process itself. And I think that's an opportunity. And again, I don't think that the maturity is there. And Gartner, in fact, has predicted in recent one of the articles that majority of the applications that are being built today on blockchain will probably need to be rebuilt in future, mainly because we will see a lot more newer standards being developed. Companies are coming up with new ways of doing some of these processes. And I think that's an opportunity, clearly, but that is, we see as the new frontier on how a technology across industry, I would say, right? I mean, if you think about the origin of blockchain, where it came from, and cross-industry application of some of those core technology.
And that makes sense. I think you mentioned something very interesting for transparency, which is, I think, really, really big. So when I switch over and look at the consumer side of it, if you've ordered something, or if you've gone to a manufacturer, or say even ordered a pizza for that matter, what is interesting is you might go to an online ordering portal, and then there might be some sort of a bot that is having a conversation with you as far as what you would like to do. And from there, you start seeing the entire process. One very interesting example, if you were to order pizza, let's say from Domino's, they have a really cool animation where you can see when the pizza went into the oven, when somebody picked it up, and they're driving over to deliver it to you. But more than that, I wonder if there's more room for something like a robotic process automation, the RPA processes, if you will, bots being a part of it. If there's room for any of those beyond the usual back office processing to interact with customers, where you might be doing some manufacturing, and then using tools like blockchain to increase the trust, but also be transparent and expose that to the end consumer to increase the confidence and therefore satisfaction as well.
Yeah, I think we are just probably at the beginning of how we start to view RPAs, or robotic process automation per se. It's an important conversation, obviously, from an industry perspective. Predominantly, what we have seen is application of RPAs are more to do with the automation within the back office systems, right, frameworks. That's where majority of the framework actually had originated. But I think its application is increasing more and more to create intelligent processes. And I think There are fundamental characteristics where we see its application makes it a lot more effective. And part of it is, again, rooted in our past, essentially, because if you really think about enterprise systems or enterprise environment, they consist of disparate systems. How do you basically create an intelligent process to build for the future? Because you can't rip out and replace with a brand new application. The investment requirements are so too huge and potential to disrupt the businesses too at the same time. And so the idea behind where robotic process automation can bring together or create these intelligent processes for that we are so craving for, that we see are going to provide that business difference. And there are other characteristics that we look at it too. Like, for example, it's too complex for fast development, as an example. Or security and auditability is a key requirement where just integration is not good enough. And this is where we see that RPA playing an important role in automating many of those key processes, whether it is in supply chain, like, for example, inventory management, or when you have the buffer stock, but when certain buffer stock goes below a certain level, it automatically reorders, as an example. Or in transportation logistics side of it. And those are some of these clearly great examples of how multiple disparate systems being integrated together to create a automated process within that step before moving to that next evolution of the process itself.
Wonderful. So all of the, let's say, the sensors, RPA, blockchain, all the digitizing, if you will, from a manufacturing standpoint, there's tons and tons of data being generated out of those. And we've seen usually if it's what's typically called a human-generated data, or if somebody's sitting in front of a computer and typing something in, the machine-generated data is obviously much more because they're sending in telemetry or any other information that's coming in. So to that end, from a manufacturing standpoint, if you're applying warranties or if you're applying any sort of like a feedback loop, if you will, to improve some of your products, to improve your services going forward, how do you see that? What are your thoughts on managing that data and managing that process, if you will, from a manufacturing standpoint?
Yeah, and I think that's the fundamental to how the organizations are evolving today, because data is the foundation for doing many of those things. And within manufacturing industry, we have created basically a framework that is driving the transformation. And so if you really look into this framework, there are a couple of interesting construct that you can actually see. One is the transformation pillars. And I think this is important to understand, is that businesses still operates depending on what their key objectives are. And if you really think about it, that a business operates to serve their customers. And so it's about engaging with the customers. That's one of the pillars of a transformation. It's about the people who serve also those customers. And I think that's where it comes down to that we need to think about that people, processes, and how do you empower those employees to deliver those transformative experience to their customers. So that is another pillar of it. The third area obviously goes down into the operational side of it, whether it is in the sales or whether it is in manufacturing or whether it is in the service sector, as an example. And I think, optimizing that operation is the third pillar. And then, obviously, we are talking about the products that are being manufactured and how do you create that next generation connected product that delivers the kind of services we are talking about. Is also a way how you see driving that transformation end to end across the organization per se. And to be able to support these various constructs for a large manufacturing enterprise, or any enterprise for that matter, you need that foundation of a platform that's basically a trusted technology, provides the level of security, compliance, privacy, transparency, all of those aspects of it. Whether it is, and again, you go back to that original construct of the intelligent cloud and the intelligent edge, it doesn't matter where the computing needs to be, because that will be delivered. That's probably being addressed already as part of it. But when you think about the data that gets generated, and you're rethinking about the data to the outcomes that it is going to drive. And so this is for the first time when we are able to bring all of these data, say, for example, within supply chain, now I can bring together the data from the customer side to be able to look into why certain experiences are lacking or a customer has challenges, we can now identify the problem could have occurred through the entire manufacturing process or within the supply chain coming from the supplier end of it, or it could be completely different in terms of the product design itself. So there are so many ways how you can now start to look at it because you're thinking about it from an outcome perspective. But that itself allows organization to now start rethinking the processes and making those incremental changes within the processes. And again, when you think about how IoT is enabling the traditional way how supply chain used to be look at it, from example of a sensor-based replenishment. And what does it do is you're now redoing the planning processes very differently because now you know exactly at what level or when a customer is likely to reorder for a replenishment perspective. And that changes the way how you actually think about the planning processes across the entire horizon. That's just one of those examples of it. And I think, that enables creation of new business models, like, for example, being able to detect potential failure that might happen. How do I position my spare materials? Or even for that matter, creating a brand new business supply chain model where I could actually 3D print closer to the customer, depending on what that requirement might look like. Enable it with blockchain as an example. And so there are these newer capabilities, what we are starting to see that's enabling rethinking of those business models for many of the customers. Because, early days, if you really think about how supply chain and how manufacturing has evolved, the whole area around the services side of it was predominantly considered as a cost. But now people are rethinking about that with product as a service, creating that more like a product as a service, which is basically a profit center. And this is a shift that we will see continue to evolve within this particular segment going forward.
So that makes sense. And I think that kind of gives us an opportunity to talk about many more things in the future in terms of either IoT and sensors or blockchain or RPA or even digital twin for that matter. I think since we're on the topic of data, I think the one interesting thing that I would like to talk about a little bit is the warranty and that portion of manufacturing. And what we've seen, so you mentioned a couple of things in terms of the early detection or detecting failures. So to jump in, one of the things we've seen from an information standpoint, if you will, the way you figure out there was a failure of a product, or when people come back and say, hey, this isn't working, or I need a replacement, things like that, typically you're providing some sort of a warranty to your product. And we're looking at the warranty information, the claims, and any supplementary data that comes along with it is very useful information for product quality and reliability as well. So in addition to maybe the transparency and the trust, there's also the other aspect where you know for a fact that something is very, very reliable. And people tend to talk about some of them. I remember when I was looking to buy a car, and I was just talking to some friends, I kept hearing some brands over and over and over. And the pitch there was, oh, these cars are very reliable. They've been on the roads for more than 30, 40, 50 years. And then you'll see some cars still from the 80s on the road, and it's all good. They're very reliable. And I think that kind of plays a big part in terms of how a manufacturer can improve from a standpoint of transforming products. Let's say if we were to take that pillar as one of the examples, I think that's big. And then trying to figure out these early warnings or any abnormalities in the product or failures, things like that, and to provide useful information for the engineers, for the reliability team, to kind of improve from there. So to that end, at Nihilent, we've come up with a solution, and we call it Citing2 for warranty analytics. And really what that solution does is addresses some of these challenges where we can take data from the warranty systems, analyze that data, and then produce some meaningful reports to customers so they can act on it. And one of the biggest things we've seen is typically the warranty cost, if you will, or what is referred to as a warranty reserve, is kind of used up more because of poor quality, either poor quality of parts that are going into the product, or poor quality maybe in terms of the process, or just overall poor quality in the manufacturing process itself. that causes some of these challenges. We've seen some interesting trends too in terms of maybe the manufacturing itself did not have any problems. However, the usage of the product, and one very interesting example here was, let's say, a window. Maybe the window, when it was manufactured, the glass was perfect, there's absolutely no issues with it, but it has a requirement of it needs to be installed a certain way. And so if you as a homeowner, let's say, just go and buy this glass at a store or windows at a store and go install them yourself, and maybe you're not following the standard process or you're not hiring somebody who's certified to do the installation, there's obviously the possibility that you might have a failure in that window. And then that gets chalked up to poor manufacturing, which maybe sometimes it isn't, or maybe there's the opportunity to improve how the installation process could work. And so we've seen some very interesting scenarios like that as we worked with customers. So to that end, we've come up with a solution where we're able to provide these insights to the customers. Some of the interesting pieces, and we'll walk through the demo here as well. I'm going to actually switch over to the demo and kind of walk through some of the key areas. So one thing we have here, I'm going to go full screen on the board here. So this is all sample data, but you'll see registrations that were done. So if you're, let's say, a car manufacturer or something like that, when you sell that product, it's obviously registered in terms of who bought it. But if you've got a warranty claim on smaller appliance, let's say that you go buy at a big box store, well, you don't possibly get all the registrations the day off, or there's a less chance that somebody goes and buys that product and you have some sort of a warranty card, let's say, that sits in the box. There's not as much of a chance that somebody's going to go do the registration. What it causes as a potential challenge, though, is you don't have the ability then to track and say, oh, something got registered on this day, and then you saw a claim on that product at this point of time. So therefore, giving you some sort of aging as well. There's different conditions, of course, and so from our solution standpoint, we have the ability to look at what the registrations were. So we have the ability to say there were these many registrations and then by customer location. But then we also can look at the overall claims and how that was flowing. And we can look at quarterly what kind of dollar amounts are seeing on the claims. And then from there, how many customers had claims that were filed in, how many claims per customer, things like that. You can also drill down into individual locations in terms of maybe these are manufacturing plants that are coming online, and maybe these are processes that have been introduced or new processes that have been introduced in manufacturing plants that potentially have challenges that need to get ironed out. So that's something interesting to then figure out in terms of what that looks like and go and drill down into more details. Or from there, when you look at the details, you can start looking at how many claims and what did the aging look like. So I'm going to make this report a little bigger. One of the things we see in this particular report is over a period of time. So this is a time frame for about 2 years. You see the claims decreasing in there. And what is interesting to find out here is, are the claims decreasing because I have a warranty of 2 years on the product? Or are the claims decreasing because that's actually typically what we are seeing? And the trend is we're seeing a majority of the claims in the first year, not as much in the second year. So we can start improving on how the utilization happens in the first year, depending on whatever product you're selling. So those are some very interesting scenarios that we can look at. Obviously, this particular sample data is for bicycles. And so we can look at what were the majority of claims in what area. Was there a particular code or was there a particular system or system description that was associated with the part? There's also the case of how many claims came in as a part of, say, the standard warranty. So maybe this is an automobile and saying there's a standard warranty. What came in as an extended warranty? Or was there more like goodwill gesture where something was filed under warranty just to make sure that the customer was happy with the product? So we are able to report off of all of those, and then we can take that information and say, here's what the analysis looks like. We can obviously also look at what were the claims per unit. So the interesting piece here is for every particular individual unit that makes up a product, we can also track down claims for that. And for manufacturers, now this depends on what kind of processes they follow, but we do have the ability to use a Six Sigma control chart for the input side of the process, if you will. to then look at what kind of claims were coming in and what kind of processes maybe were impacted or improved, and then how can we track those, which then gets us into forecasting to say what kind of forecasts can we expect over a period of time, or what do we see as forecasts for this month, the remainder of this month, or this quarter, or this year, or whatever the case is. And what's super interesting here is we can then look at, was our planning correct? Did we plan the reserves correctly? That also then drives into an early detection to say, are these particular pieces, are these particular units failing more often than not? Is there a case where we are seeing more challenges on one product versus the other? And in this particular case, for these bicycles, we are seeing there were some cogs that were attached to chains in the bicycle that had abnormal wear. So that brings up the question of, should we look at a different way of maybe installing these, or should we look at different materials and then figure out a different process to make this work? And so that kind of falls into the early detection. Switching to a different set of reports here, what is also interesting at that point is to look at where these claims qualified correctly. Are we able to look at that particular data and say, these claims were filed in this particular format, and maybe that's not the right one to look at. So again, I'm going to maximize these reports as well. So we'll switch to this other set of reports that talks to us about analyzing the claims. And we're using natural language processing to look at what was the common particular claim. And what's interesting here is to look at what caused a particular problem. So like we saw in the earlier example, if this was a chain on a bicycle that was having problems, and if somebody put a text around it, what we've seen is the largest amount of information is typically available in the comments that go with the claim, where either the technician or the customer might have filed something in terms of, this is something that's working, or this was an issue, or this wasn't working. And then those comments are extremely important to figure out what might have gone wrong. That also allows us the ability to do a comparison here. So we've got two different codes for code 1 and code 2. We were super creative with the names, but really the idea was this particular claim was filed under a particular code for what failed. And then based on the comments, do we think that is the exact same thing? Or based on the comments, do we think this might have to be filed under something differently? How do we see that happening? That's something we can do really, really well using natural language processing and text analytics. Something I would like to call out here as we go into some of the additional reports quickly is this entire solution is running on the Microsoft Azure platform, and therefore uses all the machine learning, all the cognitive analytics, the natural language processing, all of those features available, super powerful features that are available in the cloud, like Indranil mentioned earlier in terms of the intelligent cloud. And all these reports are delivered through Power BI as the front end, which is the analytics tool. And these can also be integrated into customers' existing systems in an embedded format. So some additional things for outlier detection, we can look at outlier detections since the day of purchase. This ties into the original report that we looked at from a registration standpoint. And so we can look at when a registration happened, and based off of that, what kind of outliers are we seeing where for this particular product, we see maybe a failure in the first 6 months, and suddenly we start seeing failures for that same product in month 8 to 12 maybe, or something like that. We have the ability to look at that. Or we can look at, was there a difference in the claim? So in the earlier report, we saw that these claims were an average of so many dollars. Well, suddenly did that claim amount change? And if it did, what changed in that claim amount? Was there a case where something was being used more often than not, or was there a case where just the labor prices increased, or was there a case where we are seeing some additional parts failing and therefore there's an additional cost for replacement? So we're able to provide all of those. We can also integrate our weather analytics solution, and then we are able to tie that into looking at what were the environmental factors maybe that were in play at the time, and was there something that was adding up to the failures. So as a summary for the warranty solution, we're able to look at early detection and identifying a root cause, therefore doing an early mitigation of problems. We're able to reduce the legal exposure, obviously, based off of the information that's available. Also to look at how many parts of the whole or what percentage of the whole did the claims come in for, what was affected and by how much. So we're able to look at all of those. Obviously, we have an increased accuracy for forecasting what the remaining claims look like. And then from there, we can improve efficiencies in the supply chain as well. The ultimate goal, obviously, being to manage the reserves better, manage the warranty cost better, and improve customer satisfaction. So that's our summary for what we are able to offer as a part of the solution. You can always contact us for more information. We're happy to get into a conversation about how the solution can help you. And Indranil, thank you for joining us. So this was very informative in terms of what you're seeing from a manufacturing and industry standpoint. And I look forward to some of our future sessions to talk a little more in depth about other topics like maybe IoT or RPA or blockchain and the like. Thank you all for joining us. We
Thank
look
you.
forward to seeing you in the future.